Hello everyone. In this session, we are learning about angles made by a transversal with two parallel lines. So for students, whichever the angles you want to show, make it as a text option. So I want to show first interior angles. Say OK. Go to move option. Select interior angles. Make it bold. Increase the size. So hide. So again you can click text option. So I want to show exterior angles. Say OK. Again the same process. Go to move. Click exterior angles. Make it bold. Increase the size. So more what we want to show, we can show corresponding angles. Corresponding angles. Yes. Then go to move. Click on corresponding angles. Make it bold. Increase the size. So again hide. Then go to text. So we want to show alternate interior angles. Alternate interior angles. Then alternate exterior angles. Exterior angles. So go to move. Click on alternate exterior angles. Make it bold and increase the size. So again I'm hiding. So we can show allied angles. The angles which are on the same side of the transversal, which can be interior or exteriors, which makes supplementary. Allied angles. Allied angles. Bold, and I am increasing the size. So you can say the angles on the same side of the transversal, it can be interior or exterior, makes 180 degrees. So they are called allied angles. So we want to show corresponding angles, alternate interior angles, alternate exterior angles, and allied angles. So these are the properties whenever a transversal cuts two parallel lines. Whenever a transversal cuts two parallel lines, these are the properties which we can see. So let us start. Take a line. Keep a point below the line. Take parallel line which passes through C and parallel to AB. And keep a point on this line. You can move the point. Take another line which cuts these two lines in two distinct points. Then the line is called a transversal. A transversal cuts two or more parallel lines at two distinct points. So now I am taking the intersecting point. So this is the intersecting point. So if you observe at two distinct points, a transversal cuts at two distinct points. Now I'm taking a circle with center and radius. I'm taking 1 and here also with 1 centimeter radius. Now I'm constructing sectors, circular sectors. First to take the intersection points. Click on circle and the line. Then you will get automatically intersecting points. Click on the circle and the line. Then here also click on the circle and the line. Circle and the line. Now you have intersecting points and the 4 angles here and 4 angles here. Total 8 angles are formed. Total 8 angles are formed. Now start constructing the sectors. So this is the first sector. Now in the same process I am doing the second one. Now third sector and then fourth sector. Now this is done. I'm moving on to this side. Again first sector, then second sector, then third sector, then fourth. I constructed all 8 sectors. Now I'm filling colors. Okay, select the sector. Automatically you can see in graphic view colors are displayed. So increase the opacity. You can fill the colors. Now another sector, change whichever the color you want and increase opacity. Now third one, I'm taking yellow. Yes, now fourth one, we can take another color. I'm taking pink. Okay, same way here also select the sector and fill the colors. Increase the opacity. Now take next sector. I'm taking purple color. Then here light blue. So here I'm taking green. So I finished all sectors. I filled with colors. Now it's a very, very important process. So what I am doing is I am translating these sectors using vector. So here I am going. So you can observe vector. From this point, take a vector. Now go to translate option. Translate by vector. Select translate by vector. Select the object which you translate through the vector. So I'm taking a sector and selecting the vector. Automatically it comes. Now observe the movement. You can see it is moving. Correct? It is moving. Okay, once this is completed, go to the algebra view. So whichever the one you don't want, you have to hide it. Like I don't want the vector. I don't want E dash. I don't want the point Q. So observe now. I can move this one and keep it here. Whenever we want that hand symbol is there, we can move and show it. Okay, we can move and show this one. Now same way I am constructing all sectors in the same way, but you have to select it very carefully. First I am selecting a vector, then translate by vector. I am selecting, select the sector and vector. Automatically you will see. Then first observe the piece, that sector, how it is moving. Okay. Then go to algebraic view. So whichever the points you don't want, hide it. I don't want point R. I don't want this vector. Then Q dash. Now you can see this is Q1 is moving. Okay. Now same way this side also I will construct a vector from the point, then translate by vector, select the sector and vector, then translate. The same way now point to be hide, vector to be hide and k dash to be hide. Then automatically you can show it to the students how it is moving. Okay. Then same way here also construct vector. Okay. Then translate by vector. Select the sector and vector. Now once translate the piece. Then again go to algebraic view, hide T point, hide A vector, hide P dash. We want this one, then we will keep it here. Okay. Okay, this we will keep it here. Okay, then when we want to show, we will show it to the students. Again, same way I am constructing here also. Now, a vector, translate by vector, select the sector and select the, yes, now so I'm selecting this sector and then vector. Now translate. Okay, whichever you don't want, hide it. So I don't want point U and vector and R dash. Then you can move. Okay, then same way again vector, then translate sector and vector. So you take the point here. Now hide point V vector D1. Now you can move. Okay, next same way. Here also I am constructing a vector, then translate, select the sector and vector, then move. Same way I'm going here. I'm hiding my point W, vector and this one. Okay, then again vector, only for this piece I left it. So vector, then translate by vector, select the sector and the vector, then translate. Then same way hide point Z, vector and this point. Okay. Now okay, now See, we will go to algebraic view. So first I want to explain interior angles. So what are interior angles? Okay, first I'll show this one, this one, this one, and these four are interior angles. I won't show any other angles. So we will explain the students. These four are interior angles. Okay, then hide interior angles, keep it here again. So then we will explain students what are exterior angles. Okay, then so what are exterior angles? You can show these four are exterior angles. So these four are exterior angles. Now I want to show corresponding angles. Okay, we can place it here again and we can explain the students what are corresponding angles. The angles which are on the same side of the transversal, one interior, one exterior makes corresponding angles. Now you can show this sector and this sector makes corresponding angles. You can pull this one and keep it on this, and you can explain they both are equal. So corresponding angles are equal, and you can show these two are corresponding angles, and then this one and this one. So these two are corresponding angles, interior angles on the same, the angles which are on the same side of the transversal, one interior and one exterior, one exterior, one interior, one interior, one exterior. Here also same side of the transversal, you can explain. So you can see the sector which is selected, one exterior, one interior. Same way, one, so which is selected. So I want P dash. So this is selected. This is selected. Then we want to show. So now corresponding angles we explained. So we can show now alternate interior and alternate exterior angles. So we can hide corresponding angles. And now we will show alternate interior angles. So alternate interior angles. Yes, these two are alternate interior angles. So these two are alternate. These two are alternate interior angles. So now we can show alternate exterior angles. Keep it again. We can show it whether they are equal also or not. So keeping one sector on the another. So now we are showing alternate exterior angles. So alternate exterior angles, take this exterior angle. So these two are alternate exterior angles. So you can show alternate exterior angles. Yes, alternate exterior angles, where you can see the letter Z, the pointer, this side, the letter Z, the pointer. So these are called alternate exterior angles. Yes, then we can show allied angles. So what are allied angles? Angles on the same side of the transversal. We can say co-interior angles, which makes supplementary. Now observe, so angles on the same side of the transversal. So both interior. So observe, we can keep here, both together makes 180 degrees. So both together makes 180 degrees. Angles on the same side of the transversal, both interior or exterior makes 180 degrees. They are called allied angles. You can take, say, observe. So these two also you can keep it here and explain. These two makes 180 degrees. So angles on the same side of the transversal, both interior or both exterior, makes supplementary. So they are called allied angles. We showed interior angles, we showed exterior angles, we showed corresponding angles, alternate interior angles, alternate exterior angles, and allied angles. You can show it this side also. So this sector and this sector. So observe here which is moving also you can observe. So which part we are selecting. Yes, keep it here and check. These two makes 180 degrees. Same way, observe here the sector, this sector, and so sector R dash we want. So these two are also makes 180 degrees. Yes. Now we learnt about angles made by a transversal with two parallel lines.